A bee population is measured each week and the results are plotted on the graph. Here we see a graph with number of weeks on the horizontal axis and the bee population on the vertical axis. We want to write an equation that models the bee population X weeks after it is first measured. Let's use our graph to make a table of values. So we are going to make a table comparing weeks, and the bee population. In week 0, we can see that there are 500 bees. So initially, we start out with 500 bees. Week 1, there are 1,000 bees. In week 2, there are 2,000 bees. And by week 3, there are 4,000 bees. Looking at this table, I can see that I do not have a linear relationship because the number of bees is not increasing by adding the same amount every week. We can also see this on the graph. This graph, if I were to connect the points, they would not make a straight line, so that confirms that this is indeed not a linear situation. This situation is exponential. So we are going to need to write an exponential equation, and the basic format of an exponential equation is y equals a times b to the power of x, where a is the initial value and b is the growth factor. Or what we are multiplying by, in this case each week. Looking at our table, we can see that in week 1 there were 1,000 bees, which is double the number of bees that there were in week 0, right? 1,000 is double 500, or 2 times 500. In week 2, there were 2,000 bees, which is double, or 2 times 1,000 the week before. Week 3, same thing, there were 4,000 bees, which is double the previous week. 2,000 times 2 is 4,000. This tells us that our factor is multiply by 2. So we can write our equation y equals, we know we started out with 500 bees, our initial value. And we just confirmed in our table that each week the number of bees was doubling or multiplying by 2. And then we have our exponent x. And that's it.